to right, you have to visualize with respect to the time data, right? Or you might have seen the last decade, the big data was very popular, right? So all these are interrelated, right? When somebody is mining the data, right? So they require the knowledge of statistics and machine learning, right, to know what is the exact behavior of the data, right? To extract the knowledge on the data, right? So what I will do here, we will focus on statistics and machine learning. I'm not going into the deep learning part. Maybe I'll give some applications on deep learning. So we will focus on the statistics and machine learning part. All right. So where it involves, or in order to extract the information from the data, you require these two major things initially. All right. So what are the different type of data? Right. So you have 1D data. For example, any text that you are seeing, right? So in the newspaper, so you will get several information, right? So they are all in the form of 1D data. Or suppose you are looking for a hotel, right? So immediately what you will do, you will see the feedback about the hotel, correct? So as a professor, right? So I may expect the feedback from the students. So it is like a 1D data. Right, the students are writing some, they're giving some marks out of 5 or out of 10, right? So these are all considered as a 1D data. What about 2D data? So any image that you're seeing, nowadays everybody is using Facebook or WhatsApp, correct? So you will have the 2-dimensional image data. So from the 2-dimensional image data, what you can infer? Right? Suppose some images are given, or you are looking for some person, correct? So you are identifying matching, correct? So the image data is considered as the 2-dimensional data. Similarly, you have a multi-dimensional data, right? Any video data is a multi-dimensional data. Nowadays, CCTV is very popular, all right? So they do the analytics on that. For example, in a particular time, there may be some incident, correct? Or in an ATM, people may, right, do the theft, correct, or stealing the money. Or in a cricket or football stadium, there may be a fight, all right? So in order to analyze this, all right, nowadays, as I said, CCTV is very popular. For example, you have assumed that you have 4 days data with you, 4 complete days data with you, and you are looking for 1 or 2 persons. So they may appear 1 or 2 frames. So 4 days video you have to analyze. You have to spend 4 days manually if you have to analyze the video. Right? You have to spend 4 complete days. You may not even finish. So then in this scenario, can we use machine learning? Right, so you have a data, you have a multidimensional data, video data. So can I mine the data? Right, so can I find the information from these data? Right, similarly, satellite images. Satellite image data is a multidimensional data. Right, so they have it is of the form XY image, and then 3rd dimension they call a band. Right, the band size may be 128 or 256, something like that. It is in the 3rd dimension. Right, so these are all, I talked about text data, right? 1D data, maybe it involve only the numbers or the signal processing, right? Any speech processing is a 1-dimensional data, right? Apart from the text data, any speech, right? For example, the signal, this right webinar is being recorded. It's a signal. So the signal will be stored in 1-dimensional form. So these are all the different data, all right? So whatever problem you solve in machine learning or artificial intelligence, it will be classified one of these data, right? So for example, you have assumed that you have the speech processing data, right? It will be exactly like this. right? The one you are seeing over here, it will be exactly like this, right? And then if I apply, so let us assume that I'll apply some Fourier transform or the wavelet transformation, right? To convert this from time domain to frequency domain. So I'll have a frequency domain data, right? I classify, let us say beta, alpha, gamma, delta, something like that, right? So this is one form of the data. So any problem that you are solving with the help of machine learning, right, it will fall under these data, right? It will fall under one of these data, right? Anybody who is working in data science, you can ask, right? So you can categorize, right? If you're dealing with the signal processing, it is a one-dimensional data. If you're dealing with the image processing, it is a two-dimensional data. If you're working for a video data or satellite image analysis, it's a multi-dimensional data. And many data mining researchers, right? As I had given an example, right? You're looking for a hotel, or you want to give a feedback, right? Or the famous problem called fake news generation or fake news detection, right? You might have heard the problem, fake news detection. So it requires a text data, right? So, and also nowadays NLP is very famous, natural language processing, right? So the natural language processing involves the text, right? The text is involving in natural language processing, right? So these are all the different kinds of data that you use in day-to-day life. Okay, fine. So once the data is given, right, I require some tool to analyze, right? So the tools are nothing but mathematics or statistics or machine learning, right? So where are all the applications, right? I talked about data science, so where it is being applicable. So nowadays everybody is using, right, Siri or OK Google or Alexa, right? So your morning is starting with these devices, right? So this is a virtual personal assistants, right? So for example, these are working based on natural language processing, right? So these are working on natural language processing. For example, you are training, right? You are training a model. Assume that you are training your model, right? So for example, you are asking where exactly you are, or what is meant by IIT, right? You're asking the question to Alexa, right? Somebody might have asked previously, somebody might have trained, right? Suppose I'm asking the question, what is Newton's third law? Correct? So somebody might have initially trained. Initially, the machine does not know what exactly it is, what exactly Newton's third law. All right? So we are keep on training the device. So we are feeding the information either in the form of speech or in the form of text, right? And then it is mining the data, let us say from the internet, right? Sometimes it will answer from the internet, it finds, for example, I want to hear some songs. All right. So it will mine from some website as well. So that means it is getting the data from several sources. So it would be trained by somebody else. All right. Somebody might have told what is Newton's third law, or it will mine from the internet sources. Right. So then it is replying. That means whatever the human, what we have done, how did you learn Newton's third law in the school? Right? Somebody might have taught you. That means you got the training. And then after sometimes, right, when the test comes, when the exam comes, when the question appears, you are writing. Right? So the training and testing, which is playing a vital role in machine learning. Right? So the virtual personal assistance is one of the applications. And also predictions while traveling. Right? So sometimes, so most of you are using Google Map. Right? So when you're traveling, so sometimes you can find if there is a traffic, let us say from Meerut to New Delhi, in my area I'm taking, right? If there is a red in the road map, I can find if it is a red, right? So that means the traffic is very high, right? How do you conclude that? How do you get this information? So many people are using mobile nowadays. So on that line, on that road, right? If many are using the internet, right? With the data nowadays, that is not a problem, right? So the number of the mobile data or the internet data acquiring in those places, it's very huge. So based on that, it's pulling the data. In fact, it is pulling the data from your mobile, right? And then informing that, find this particular lane. I have a huge data in my hand based on that, right? So the Google is analyzing. So here the traffic is very high. So that is one of the applications. So pulling the data. So it is pulling the data and is calculating whether it is a dense or let us say it's empty, the road is empty, right? So this is another application. The third one, I talked about the video surveillance. So nowadays, CCTV camera or PTC camera, they are very popular, right? Suppose I want to analyze, for example, a cricket match is given to you, right? Cricket match video is given to you, right? So you are going to mine, right? What are all the frames the batsman is hitting sixes? All right. So assume that if it is a one-day match or even a T20, it takes almost 4 hours, right? So total 4 hours, if you instead of mining, can you automate this? Right? Can you automate this? The 4 hours video is the input data, and then what are all the frames the batsman is hitting sixes? Similarly, in the video surveillance, you want to find a person, right? You want to locate some persons. Or there may be unwanted activities like fighting. Or some people may walk in the parking lot. Right? So to analyze this, the machine learning is playing a vital role. So the data here is the video data. Right? So the video data is a 3-dimensional data. So it's like an image. And every second you will have, let us say, some 80 to 100 frames. Every second. So imagine 30 minutes video is given to you. It's a huge data. It's a very big data. All right. So this is one of the applications in video surveillance. And the social media services, right? So for example, everybody is using Facebook, right? So you might have seen, suppose you want to search some person in the Facebook. What do you observe? You first observe that, right? You can see that. Search some name. It will first give your friend, all right? It will give a friend. Then suppose he is not in your friends list, it will go to a friend of friend, and friend of friend of friend, and so on. All right. So it will try to search how far they are related to you. Right. Similarly, LinkedIn, right? First connection, second connection, and third connection, and so on. So how far they are related? It's like a radius. So they use the concept called graph search, right? So they, in the social media, they use the concept called graph search, right? So the graphs, so there are several graph-based algorithms in machine learning, tree-based algorithm in machine learning, right? So they use this. Similarly, the search engine results refining, right? So sometimes, okay, suppose if you type IIT Roorkee, you will get in a page, you will get all the information maybe, right, relevant to IIT Roorkee. But if you try some XYZ, right, so try some XYZ link, initially you may not find, right? Initially, first time you may not find. Assume that this XYZ is not very popular, right? So, okay, fine. You are trying to find out the location and assume that at one point of time, this XYZ is becoming popular, right? So that will be based on the number of searches, right, that made by the user, right? The data is being collected by the users, right? So you are going to type something. This XYZ, you are going to type something, right? Assume that many users, hundreds of thousands of or 100,000 of people are trying to type the same, this XYZ at one point of time, right? So the search engine will understand that, okay, the users want to know about this XYZ, right? So then it will start giving the optimal result. So it may take 15 days or 1 month, right? So you might have experienced this. So these are all the applications are based on the data science, and in fact, the machine learning is a tool to solve all these problems. Right. So when machine learning, before machine learning era, right? Assume that, in fact, it started long back in 80s itself, right? The people have worked on neural networks, right? So you might have seen various engineers, right? So given set of data points, they try to fit a straight line. You call it as a linear regression, right? The regression is playing a vital role here. So where exactly? So for example, assume that you are given, all right, age and the blood pressure. A person is there, human is there. Age is given, right, which is acting as an independent variable, right? And the blood pressure, which is a target variable, right? One I call it as X and another one is Y. All right, I take two parameters. One is X and another one is Y. All right. So you are given, all right. Assume that you are given. I'll go back to the previous slide again. So you are given, right, age, and you are also given the blood pressure. So now the idea is, right, so you can see here, you can see the data. I'll show the data. All right. So here you are given, this is the data. So I have the age data, right? So this you go, this is the age, fine. And this is the corresponding blood pressure unit, right? Some unit. So this X is called the independent variable and Y is the dependent variable, right? Or you call it as a target variable. So now, if you are given this data, right? I'm talking about in 1980s, right? So you are given 25, 120 or 36, 135, right? So when you are given the data like this, so what you will do, you will try to plot this, right? You will try to plot this, right? How do you plot this? I'll just take out the, right? So you will try to plot like this, right? So this is the one, right? These are the points you have plotted. So now what you will do, you will try to fit this in a straight line, right? So to fit this in a straight line, you require the equation. What is the equation? Y is equal to beta naught plus beta 1x plus some epsilon, right? It's some like an error kind of. Right now we'll avoid it. So basically you might have studied y is equal to mx plus c, right? Your m is the slope and c is nothing but the intercept, right? So the prior to your machine learning era, any data are given like this. So because I'm talking about the data, this is a 2D data. So I'll try to fit a straight line. The straight line is like a red in color, right? So as I said, m is a slope, beta 1 is a slope here, and it's the intercept, right? I'll try to find this. So how do you find? So I'll find using the, right? I'll find this using least square approximation method, right? So least square technique. So that means when you look at here, right? So in the previous slide, right? So you can find, right? Some of them are on the line. Some of the points are very nearby. This is the optimal line. Assume that, right? This is the optimal line where the distance between this line and a point, right? So distance between the line and a point. So the square of the distance is as minimum as possible, right? Square of all this distance. So let us say D1, D2, D3, etc. up to Dn. So the square of this D1 squared plus D2 squared plus Dn squared as minimum as possible. So that is what, right? The data is being analyzed and then they got the result. So how do you do? So I'll try to put the approximate line I call y bar, right, with mx plus c, right, b1x plus b naught or beta 1x plus beta naught. And then I'm using the summation. So least square, right, the d1 squared plus d2 squared, right? So d1 squared plus d2 squared, something like that. I take a summation, that means di squared, summation of di squared, right? I got like this. So this error should be as minimum as possible, right? So this error should be as minimum as possible. That is what they worked out, right? In order to do this, you have beta naught and beta 1. You have to find out these parameters. So that means I'll do, right, I'll find dou E by dou B, dou B naught, so which is equal to 0. First order partial derivative of E, let us assume that this is E, with respect to dou B naught and equal to 0. And second one is dou E by dou B1, which is equal to 0. So now I will get two linear equations with B naught and B1. And when I solve this, I will get this beta naught and B1. That means you are able to find out the line. Right? You may ask the question, what is the application of finding out? What is the use of this finding the line? So now there are some missing data, right? So for example, here 50 to 55, this is 50 and this may be 55. Can I find at 52, what is the blood pressure? At 40, what is the blood pressure? At 45, what is the blood pressure? Or let us say at 90, what is the blood pressure? So for this, all right, so you are given a discrete data. Then once you are drawing a line, it is becoming continuous, right? The discrete data, it is becoming continuous. So not only 40, I can find anything else, right? So for this, the linear regression was introduced and it was useful, right? So given data like this, people have used the linear regression model and they got the results. All right. So I can solve. I said that I got the two linear equations and solve for B naught and B1. Okay. So now I have some interesting data. All right. So let us say I'll go for the nonlinear regression. So from the year 1964, right, I have a price of 24 carat per 100 grams gold. So imagine in 1964, the rate was 63 rupees 25 paise, 10 gram gold, right? And 10 years after, 1974, it became 506. Gradually, it is increased. Right? I have this data. And 1975, it became 540. And if you look, 1985, 2130, and 1986, 2140, and 1996. It became 5,160. All right. And 2007, a 10 gram gold was 10,800, a 24 karat gold. And 2017, it became 29,667. Right. So till today. So today is approximately 10 gram gold. I'm talking about 24 karat, 52,690. Right. So I have a data from 1964 to this date till today. Right. So now what I will do, I have a data in my hand. Now I will do some analysis. Right. First step, you plot this. Right. So this is in 1964. This is the case. 64 rupees. And today it is 54,000 rupees. So it has gone like this. Right. So now my question is, right, you can also answer. Not sure whether you can able to answer only in the question and answer, or you can talk. I'm not sure. Maybe Ritesh can tell me. So what will be the rate of gold in 2032 and 2042? Any guess? Are you hearing me? Ritesh, are you there?
Yes, sir. Yes, sir. Yeah.
Okay, fine. I'm just cross-checking.
Yeah, sir. I'm here.
So this is the gold rate, and okay, fine, good, thanks. So this is the gold rate, right? So in 1964 it was 64 rupees or 63 rupees 25 paise, and now we are here in 2022, right? So it is 54,000, something like that, right? So now my question is, what is the prediction in 2032 and in 2042, next 20 years lane, 10 years, 10 years? Any guess from this data? I'm just checking whether you are answering or not. From the data, it can be extrapolated. 1.5 lakh will be exponential. Yes, Ashwin Gaur has said exponential. Yes. So when you look at this curve, immediately you can think of this exponential curve, right? So immediately one person answer, right? Almost like this. I'm fitting this, right? So this is a fitting. Maybe I'll use a red in color. So I'm fitting the data. So this is nonlinear regression. Approximately, don't take it, right? Whatever I'm, right? So I'm trying to fit this, right? And then I'll extrapolate. This data can go. It's like the curve is like A e power alpha x plus b, right? A e power alpha x, or simply you can write y is equal to e power x, right? So the curve goes like this. So up to 2022, right? So I have some set of points. You have some dotted points. Here you are seeing some dotted points, right? And then I'm fitting the curve. So when you're looking at the curve, this is an exponential curve. So it is of the form like this. So now I substitute for, let us say, 2032, year 2032. What is the output I'm going to get? And similarly, try with 2042. What is the output you're going to get? So this is called a nonlinear regression. So I have a data, right? The gold data, right? So the prediction will be like this. So one of you predicted almost right, 1.5 lakhs, right? So someone predicted, yes, John V predicted it was 1.5 lakhs. Almost you're right. Right? So like this, you can predict the data. Maybe you may ask the question, what is this A and B? So this A and B, it is acting like a weight. This is called weight, right? It depends on, right, many factors, right? This is W0, this is W1, this is a weight. So based on the weight, you are going to predict. But the main function is the exponential, e power x. Right, the curve is e power x, and alpha, you have another weight, third weight, right? So based on this, I can do a prediction, right? So this is based on the nonlinear data, nonlinear regression data, right? So like this, you will learn, right? Or you have to learn, if you have to be familiar in machine learning, you have to learn all these topics initially. All right. So you need basic statistics. Then I talked about linear regression. Then there is a concept called logistic regression. And you require some mathematics for like a linear algebra, right? You require calculus, right? You may require differential equations, right? All the mathematics that is involved or the application for machine learning, you have to study. And then clustering. What is the difference between clustering and classification? right? You have to study clustering. K means clustering. Fuzzy C means clustering, right? So you have to study the feature extraction algorithm called K nearest neighbor. Principal component analysis, PCA, right? And then you have several classification algorithms. I'll talk about that. And very famous naive Bayes. Naive Bayes is based on the probabilistic model. So you require probability. The mathematics, you require probability also. And then there are several classification algorithms. You have to study artificial neural networks. So these are all the topics. When you are familiar, right? If you are familiar with these topics, right? So then you know the basics of machine learning, right? So then you study convolutional neural network. CNN is called convolutional neural network, right? So these are all the concepts. In fact, in the course, we will cover all these topics, starting from basic statistics, probability, mathematics, and then all these feature extraction and classification algorithms, right? So when I talk about machine learning algorithms, it is classified as, right? When the learning has been classified as supervised, unsupervised, and reinforcement learning. All right. So what do you mean by supervised learning? All right. Suppose there is a robot, all right, and then you have trucks of fruits. Right? There is a robot and there are trucks of fruits. The fruits means you have a grapes, apple, banana, papaya, everything. Right? The task is the robot has to classify these fruits. So that means, let us say 70% of the fruits in the truck, you are giving a training to the robot. Right? So that means you are annotating it. So you are saying that this is orange, this is apple, this is banana, this is mango, etc. Right? You are annotating. You are giving the class. You are labeling the class. And then, okay, so how do you annotate, or how do you give the training? So for example, yeah, right, the banana is completely different from apple in terms of color, in terms of shape, in terms of texture. So these color, shape, texture, they are all nothing but the features, right? Because the features are playing the important role in machine learning. Features. Extract the features. That's called feature extraction. So once it is extracting the features, that means 70% training, it is extracting the features. So now we are going for the testing. 30% of remaining fruits, I am going for the testing. Can it classify properly or not? Right? So can it classify properly or not? Correct. And then you are getting the accuracy. Okay, my algorithm, right? 99%, it is classifying exactly. So such algorithm is called supervised learning. The second one is unsupervised. So you don't have any class label, right? You are not training your robot, but can it classify, right? So based on all the features, it has to extract the features by itself, and you have to do the classification. It's unsupervised, right? The human being, right? Initially, right, when we are a 1-year-old baby, right, mother is teaching, right, the face recognition, right? So initially she's telling, he is your father, he is your brother, he is your sister, right? After 5 years or even 10 years, right, the human is becoming unsupervised. So once you see one time, you can able to distinguish, right? So that is a major difference between the supervised learning and unsupervised learning. And what do you mean by reinforcement learning? Suppose a monkey is there, all right? If it is doing a right job, you have to give a reward. Let us say a banana is a reward or a gift. If it does a job wrongly, I mean, we are going to assign a job to the monkey, right? If it does the job correctly, we are rewarding. If it is not doing correctly, we are giving a punishment. We are giving a beat. So in the process of reward and the punishment, the monkey starts working properly. right? Monkey starts working correctly, the assigned job. So we call this as reinforcement learning, right? So any data is given and you go for the machine learning algorithm, so it falls, right? One of the classification algorithm, one of the learning algorithm. So it will follow one of the learning algorithms. So it may be supervised, it may be unsupervised, or it may be the reinforcement learning. So now, in another few years, right? So almost, right? So we are going to enter the brain-computer interface, right? So we, for example, right now we are handling, for example, if I'm switching on the TV or switching on the AC, we use remote, right? Let us say after 5 to 10 years, right? After 10 to 15 years. So we enter the room and we are thinking, okay, the AC has set to 25 degrees Celsius, but I want 19 degrees Celsius, right? I'm just thinking. So brain is giving some signal. So can this signal be converted into digital? And what exactly you are thinking? So accordingly, so I'm thinking, so if it is changing to 19 degrees Celsius, it will be good. So automatically will it change? And I want to change the TV, right, from news to sports. Can it do automatically, right? So that is called the brain-computer interface, right? So for this, to collect the data from the brain, so everybody knows ECG, right? Everybody knows ECG. So in the case of a brain, we collect the data, right, putting this apparatus, it's called the EEG. EEG means electroencephalogram. Right, so the brain is divided into 4 parts, and you can see these are the electrodes, right? So these are all the electrodes, the round in shape, right? So these are all responsible for getting the data, right? So these are all responsible for getting the data from the brain, all right? So your brain is divided into 4 parts, exactly like a heart. ECG is for heart. And here you have EEG for brain, right? So divided into 4 parts, and each electrodes, you are seeing the electrodes here, right? So these are the electrodes. So this will fetch the data from the brain, right? And then, right, so for example, I want to analyze some problem, right? In fact, these are the example of the EEG device, and the round in shape is, they are nothing but the electrodes, right? So they will get the data. Suppose I'm thinking something, right? Suppose I'm eating something, and then it is giving some taste, right? For example, I'm eating mango, it's a sweet in taste, right? Or sometimes it may sour. So I may think if it is sweet, it will be good. So what exactly the taste is, right? So my brain is, right, giving some information. If it is sour in taste, right, so my mood will change, and the brain signal, right, that will generate something. Or when I am touching the hot water, immediately I am taking my fingers out. All right, how this is happening? The brain is sending a signal to your the fingertip, and automatically you are taking out. So in the same principle, right? So what exactly I'm thinking, right? So based on the EEG data, right? So can it be predictable, right? That is what the problem. So the EEG device, we are putting like this, right? A person is, let us say, watching a video. We are putting the EEG device like this, and then it will generate a data. All right. So this is a specification of the EEG data. All right. So the first one you have seen, it is a 14 channel, right? That means 14 electrodes you can see. And the specification that I mentioned, which we are in our lab, 32 to 160 channels. That means 32 to 160 electrodes. That means more in, right, more the number of channels, whatever the data that it is going to give, right? Whatever the data that EEG is going to give, it will be like exact or perfect, right? That is what the idea. So what are all the problems that you can solve? For example, prediction of advertisement, right? For example, 20 YouTube songs are given, and then you have to do the ranking. So usually what you do with the data, you will do. So given data, suppose a person is sticking, whether it is very good, excellent, the song is very good, excellent, bad or poor, right? So sentiment analysis, I can easily do it. Any statistical data, I can come out. But now your EEG apparatus is like this, right? Put it in the skull, put it in the head, right? And then it will give a signal, right? Based on this signal with sentiment analysis, right? Based on the EEG signal with sentiment analysis, right? That means a same person is giving a data as well. We are taking the brain signal also, we are taking a data also, feedback also. So it is like using EVM and ballot both in the election, right? So EEG will give a data, and the sentiment analysis and the feedback also will give a data. So based on these two data, can we perform, right? Or can we compute the rank of the songs? Assume that 20 or 200 songs are given. You have to analyze based on these two data, right? So for this, machine learning is play a vital role. So you have two different data. One is sentiment analysis data, another is a EEG data. So in both the data, find the future extraction, right? Or any statistical model, regression model. So then do the classification, right? And similarly, sentiment analysis also do the same. Extract the futures and do the classification. So now it is a multimodal, right? You have a EEG data with a weight, plus you have a sentiment analysis data with the weight. So whichever is giving higher, right? So whichever is giving higher, sorry. Right? So you have sentiment analysis data with, let us say, a weight W1. Right? Whatever score is being higher, right? You consider that is a top, that is a first rank. And then you can analyze based on this score. So one is the EEG data. So the EEG data, you are applying a machine learning algorithm. And sentiment analysis, you are applying a machine learning algorithm. Then you call this as a multimodal fusion. Right? This is called as a multimodal fusion or bimodal fusion. That means you're using both EEG data as well as, right, sentiment analysis data. Combining both, get the result. That is what the idea. So how this brain signal look? This is a one-dimensional signal, right? So for example, I am getting some green. The green in color means my signal is good. All right, it is exactly like your mobile signal, almost. Right? So it's giving a rank, second rank. Right? So this data I can use for my analysis. So this is a 14 channel. So suppose I use, let us say, 160 channel. Right? Assume that I'm using the 160 channel. Right? Assume that I'm using the 160 electrodes. So my signal will be further better. So whatever you are seeing here is a 14 channel. I'm just giving an example of a data, right? EEG data. So this is a EEG data. It's a one-dimensional signal you are seeing, right? And then I'm ranking it. One is the best. Here I am having 2 because some green signal. 2 green signal. 3 slightly better. But whereas this is a poor data, completely red, and rank is also 5. Right? So when I obtain, in fact, from the multi-channel, I am getting all these data, 160 channels, the multi-channel, I'm getting the data, and then, right, I use some filter removal, right? I use some filter to remove the noise, right? So instead of using, this is the original signal, but after removal of the noise, I use this for my further analysis. So this data is called as the EEG, right? So right now, you are seeing a big machines, right? The EEG apparatus is a big, Who knows, in another 15 to 20 years, 10 to 15 years, you may even have, you can put it in your mobile, right? You can even place the chip. It will be like a chip in a mobile, right? Suppose you are getting an email from your boss saying that you have to attend the meeting at 5 o'clock, right? And you know that you are attending this talk, you may not attend. So you are just thinking, can this go as a reply without even typing? So this is what the brain-computer interface. So this technology, who knows, it may be possible in another few years. All right. So this is one of the applications, right? So usually people use with sentiment analysis, correct? So sentiment analysis data. All right. So for example, the data mining researchers, so suppose I want to classify positive sentiment or negative sentiment. All right. I have to extract the features, right? Pre-processing, I will extract the features, train the data set, and for testing, you will go for the classifier, right? This is a standard way. And what are all the future extraction algorithms? Suppose the signal is given, right? The one-dimensional signal you have seen, right? It is given like this. How to extract the features? For example, I use this for, right, for different purpose. For example, in the banking sector. In the banking sector right now, in order to do the transaction, you use only the signature, right? The signature data is the image data. And then you are doing the classification. Signature, whether it is a matching. If it is getting matched, your process, they will process your request and then the transaction is being happened. Suppose several users are giving, right, your EEG signal data. Correct? So how do you extract the features? For example, my signal will be different from your signal, right? Whatever the brain is generating, right? How do you extract the features from the data? For example, you may use the frequency domain like a Fourier transform, like a wavelet transform, right? And these are all some of the important you will study, right? When you do machine learning course or data science course, you will study all these feature extraction algorithms, right? Independent component analysis, ICA, isomap, kernel principal component analysis, latent semantic analysis, NLP, you use this, right? Natural language processing, you use this, right? Partial least squares, PCA, principal component analysis. So these are all autoencoder in convolutional neural network, right? So these are all the future extraction algorithm. So you may have the data, all right? The data will be like, for example, I'm using the video data. Video data is very huge, right? Very big data. So I need to extract the information. I need to have only some vectors, some features out of the data because I don't want to use the huge data because I may not have the computation power. So in that case, I extract the features from the data. So for further analysis, I use only the future extracted data, right? So these are all some of the important future extraction algorithms. So when you do machine learning or data science courses, right, you will study all these important future extraction algorithms, right? And also, right, other applications like human activity analysis or recognition, right? Human activity or human activity recognition, right? For example, you have a RGB video. RGB video is a usual video, right? So here a person is, right, throwing a ball, right? A person is throwing a ball, person is hitting a ball, a person is doing, right, or catching the ball, something like that. So this I have to analyze. For example, given a video, you have to analyze a person, right? Analyze the person, the coach will do. Right. So if you go frame by frame, our human has to do this. It will take a lot of time. So can we automate this using machine learning algorithms? All right. So from the database, I use a machine learning algorithm to find the classes. For example, similarly, depth image. Similarly, the infrared images in the night. What are all the actions are going on? Right. Particularly in the border. Right. In the border security force. In fact, we are doing some work for DRDO. Right. If you look at my website, we are doing right border intrusion. People may come from border in the during night. Right at that time, right, we put the camera and it has to give, right, it has to give the signal, right? So these are all some of the applications, right, where the machine learning algorithms or even deep learning algorithms are useful. And similarly, these are all other applications like a gesture, all right. Just saying some thumbs up is a gesture. Action, a person is hitting the ball. Interaction, that means a human-human interaction, or the group activities. All right, these are the group activities. So to analyze from the data, right, from the video data, you require the machine learning algorithm. Right, we require the machine learning algorithm. Similarly, recently, many people have worked on this, right, COVID X-ray images, right? So this is a binary class problem. The left-hand side, it's a usual, right, ordinary normal person. Right-hand side, the person is suffering from COVID, right? So X-ray image data you are given, right? So here you can see in the right-hand side, you can see that, lungs and the bones are not visible. Whereas in the left-hand side, a normal person, everything is perfect, right? The bones are visible, the lungs are visible. So we know that as a human, we can able to categorize, but how the machine categorizes this, right? So you are passing the information, you are passing the features. So it has to extract the features. So when it is extracting all the features like this, right? When the machine is extracting all the, so you're giving it training. So like this, you have thousands of images or 100,000s of images. So you are giving a training, and then it will classify who are normal person, who are suffering from COVID-19. So this class of problem is called binary class problem. Right. So like this, you have so many applications. Sign language recognition. Right. For example, there are students, even in IIT Roorkee, we have Anushruti. The students cannot talk or hear, right? So they communicate each other. That is called the sign language recognition. Correct? So here it's American Sign Language, right? So you have 26 characters. So can I classify these? So any language you start with alphabet, and then go for words. So you may get the results, right? I apply the machine learning algorithm, I get 68.83 to 74%. Then I improved up to 98.83. So machine learning algorithms are like a trial and error. So once you are familiar with the letters, you go for the words, right? You go for the speech. So not only that, see, when you're putting a gadget or mobile in front of them, in front of the students, right? Whatever actions they are doing, your mobile has to give a reply. Right? So similarly, we are understanding what exactly they want to say, and we are trying to give a reply. And then the mobile will give you the action for them. Right? So that is called the sign language recognition. Another applications, right? In terms of computer vision problem. So these are all the applications. All right. So similarly, here you can see the Argentinian sign language recognition. Right. So here we applied. So these are some of the words. You can see some of the words. Right. So we applied both machine learning and deep learning algorithms. Right. Input is like a video. And from the video, I'm fetching certain data. You call it as a motion history image, dynamic image, RGB motion image, and I apply deep learning algorithm to extract the features. And right, these are the deep learning algorithm to extract the features, and machine learning algorithm for classification. So mixture of deep learning and machine learning. Can you do that? Yes, you can do that. All right. So your deep learning algorithm will give you features, and based on the features, I apply machine learning algorithm for classification. Right. So these are all some of the applications. And similarly, right, for example, these deep learning plus machine learning algorithm, accuracy is 97.81%. Right, it is accurate. All right, accuracy is 97.81%. So you have to measure what exactly the output that you are getting. That is also very important. All right. So this is the night vision data. So during night, somebody wants to communicate. All right. So like this, you have several applications in this field. All right. So in the 1 hour, I could all right, focus on the problem from the financial data to the video data. So you can imagine whatever data that you are finding in the world, you can think of applying, right, statistics, machine learning, deep learning, and then find out what exactly you are inferring from the data. That is what the main thing, right? So you have a data, all right, and use machine learning or statistics as a tool, infer the information. That is called data science. All right. So these are all some of the important classification algorithms. So initially, when you learn machine learning, so these, right, if you're attending the courses, so it will be taught, right? Logistic regression, naive-based classification, decision tree-based classification, k-nearest neighbors, support vector machines, right? Random forest, stochastic gradient. So these are all the classification algorithms. Okay, so I talked about feature extraction algorithm, and these are all nothing but the classification algorithms. Fine. So I could cover in the 1 hour, I could cover some of the data, and I have talked about what do you mean by regression, right? What do you mean by linear regression? What do you mean by non-linear regression? And we have taken up, right, 2 case studies. One is the age and blood group. Another one is gold rate. And then I focused on some of the applications towards computer vision problems, right? So basically we focused on the data, and from the data, what we are, right, how machine learning and statistics, they are useful as a tool. And then from this tool, what you are inferring from the data, which is called the data science. So if you have any questions, I'm not sure whether.
Thank you so much, sir, for the wonderful session, sir. It is quite informative. I'm sure all the participants of the webinar have also find it super informative. Guys, I mean, the request is if you have any question from sir, please put it on chat or Q&A box, and I'm sure the sir will be very happy to take those questions. Any questions you have, please put it in chat or Q&A section. So one question which came in between is that can we use the whole the data science machine learning algorithm and share price prediction, share market can be predicted, etc.
Yes.
Sure.
So there are companies, right? In fact, my student is having one company. Yeah, it's like you have to find out. See, once you have the data, right? This is the basic statistics you have to use. So once you have a data and then you are plotting it, where exactly you are going to map, right? What function? We found y is equal to e power x because of the nature of the curve. So based on the nature of the curve, what you are going to suppose a stock prediction, right? It may not be like exact e power x curve. It may be oscillating. All right. So you have to make a mathematical equation, or you use the machine learning algorithm. If you're not comfortable with the regression, go for classification, right? Or you have another regression called logistic regression.
Yeah.
Or you have a classification algorithm. So based on this, you can predict. Yes, you can do this. So there is a question, how is Indian astrological prediction different? So see, astrological data, I mean, it is depending on whether they have gone the past, or sometimes they say it is based on the future, based on the star and all, and they calculate the future, right? They know this may happen, right? I'm not saying this will happen. So this may happen. Yes, you can use the data science. You can use the data science, and you have to convert everything. There are so many stars. All the stars you have to convert into the digital data. I mean to say the numerical data. So when you are able to convert those in numerical data, yes, you can apply data science in astrology also. But for that, you have to have the domain knowledge on astrology. How you are going to? There are several stars. Those who know astrology, they know that. So how you are going to map that into the numerical value? So if you are given a numerical value to me, I will do the wonder. But astrology, it depends on how you are going to convert, right, the star data into numerical data. Yeah.
So there's another question Shri Krishna has asked. I have my UG degree in medicine. Can DS be helpful in some way to build a career in non-clinical field? Can you put a light on biostatistics?
No, even in a clinical field, it is useful. In fact, if you go through my website, 4 or 5 students of 4 or 5 PhD students have done a PhD in medical imaging. So in the medical imaging, they used machine learning and data science. For example, segmentation algorithm, right? So any medical image is being given, like MRI or CT scan or any other data, right? For example, retinal image, they have used machine learning algorithm. So it is really useful. And you are asking a career in non-clinical field. In fact, you can use the clinical field itself, right?
Sure, sir. Sir, especially the question, another question linked with this same question, sir, especially people who are coming from medical science, how quickly they can adapt the data science, technology, etc. What is the input required for people who are coming from non-maths background, sir, or non-engineering backgrounds?
For them, they can work only with languages like Python, right? Because Python is already having all the toolbox, right? For example, if they have to do same the linear regression example I had given, no need to solve, because I know their mathematical background is a little bit poor. So what they can do, but anyway, you have to learn one particular language or a software, right? So you can use it as a tool. For example, regression, or you are applying any feature extraction, or you are using some support vector machine like algorithm. You should know the commands, how to use that, right? Because as far as I know, you may not even familiar with the matrix, right? Mathematical matrix I'm talking about. So in those kind of learners or students, so they have to learn at least one programming language, I think, or a software, right? Learning a programming language or software, I mean, that doesn't require any mathematical background, right? Not much mathematical background. Yes, it is required for somehow, right? But the idea is how you are going to utilize in your application. For example, you have to analyze 3-4 algorithms in your field itself. The given medical imaging, you have to analyze. So you require at least how to use the software and the programming.
Great. Thank you so much, sir. Monica has asked about decision tree, sir. So she is asking to get some insight on decision tree.
Fine. So decision tree, it's like, right, it will work like a binary class problem, right? So whether it is like a yes or no type, right? We are going to take a decision, right? Whether the two numbers, given two numbers, A and B, whether A is less than B, right? So you are going, right, the left subtree, it will give, right, S, assume that left subtree is giving S. That means A less than B is true. On the right subtree will be giving A less than B is false. So one is true and one is false. So you are moving towards true. So you will have tree means you will have right. It will be like this. You will have several nodes. Right. For example, you will have, right. So you will have several nodes. Right. So from everywhere, so you require the concept called entropy. So this A less than B kind of, right. So each node will provide entropy, and based on this entropy, you are moving towards the path. For example, here you have, assume that. Right. So based on this, entropy will right give you certain decision whether you have to move towards left or towards right. So you're making a decision from this node. All right. So that will be calculated based on entropy. You can see the formulation for entropy, and then you are moving. All right. So here, right. Assume that your entropy is this is giving yes, this is giving no. So from here, you have to take another decision whether you are going to move here or there. So like this, you have to reach the node. For example, this is my optimal path. Assume that this is my optimal path. And then based on these nodes, right, you are going to, it will give a voting, right, whether you have been selected the correct class or not. This will give you a voting, and right, this will decide whether the decision that you have made, right, whether it is giving a correct class or not. So that is a decision tree. And then you will have a random forest. So random forest is nothing but the collection of many decision tree you may have, right? N decision tree. And N decision tree will give you the major voting, right? It is a major voting approach. Right? Among these N trees, let us say N is equal to, let us say 10. Right? So 7 trees, assume that 7 trees are giving, right, let us say S. Or it is giving a decision, or it is a vote. So 7 trees are giving one class is, right, there's a class 1. And 3 trees are giving class 2. Right? So class 1, this is a major vote. Right? You select this. So like this, your decision tree. This is a decision tree. The blue in color is a decision tree. And then your concept, the red in color is the random forest. All right. So every node, you will make a decision. You're going for the class yes or class no. Correct?
Right.
Yes, yes, no means class 1 and 2. Right? You replace 1 and 2. If you're not comfortable with yes and no, you keep 1 and 2. So whether class 1 or class 2, whether this is class 1 or class 2.
Right.
Okay? That concept is called decision.
Great, sir. Thank you so much, sir. Sir, one last question, sir. I know we exceeded time, sir. Ashwini has asked if data science can be used in supply chain management, sir.
I'm not sure because my domain knowledge is not supply chain management. Maybe I'll take your question. You can see my email, right? Ashwini, yeah. What you can do, you can because I'm not very familiar with supply chain management. Okay, maybe I'll ask my colleagues, 2 of my colleagues. One is Professor Rajat Agarwal and another one is
exactly,
Professor
sir. So
Ramesh, right? I will discuss with them, and I need a domain knowledge.
So, sir, if you don't mind, sir, if I can take that, so because I'm closely working with Professor Rajat Agarwal as well. I think, sir, I mean, in the supply chain specific program which we are doing it with IIT Roorkee in supply chain management, so we do have predictive algorithms in supply chain management, which is helping optimizing the inventory, the delivery, and optimizing the net cost of the whole supply chain management segment itself. So using the Python language itself, Professor Rajat Agarwal, sir, is teaching the optimization processes which a new age supply chain management segment is using, especially the corporates and the organizations have started.
Okay, possible. See, actually, we are focusing on the machine learning algorithms only, right? So total in and out of machine learning, but there are several applications.
Right, sir.
Right. I may not be familiar with even, let us say, some of the medical imaging.
Yeah.
Right. So it requires a domain knowledge to tell the answer. But you keep in touch, Ashwini Kumar. This is my email address, bala@cs.iitor.ac.in, and then I can help you, right? Because whatever algorithms you ask in machine learning, I can answer. But the question that you are asking is tricky for me because I am not a person of supply chain management.
Sir, thank you so much, sir. I mean, it was really great listening to you, especially.
Thank you all.
Especially, sir, the application which you have explained, the case studies which you have taken, sir.
Yeah.
It was a real privilege, sir, and we are really looking forward to see some of our participate in iHUB, DivyaSampark Data Science Machine Learning Program, also of IIT Roorkee, sir. Yes, and thank you so much, sir. I'll just take some time with participants, sir. In explaining the course, but thank you so much, sir, for explaining.
Thank you all.
Thank you.
Bye.
Thanks. Bye, sir. So, guys, I mean, it was. I'm sure all of you had wonderful session with Professor Bala, who has explained everything. Very interesting and charming of the application of data science and in medical science and several other applications we have seen in past 1.5 hour or so. Guys, I mean, as I've explained you in the early of the the beginning of the session itself, so with the help of Professor Bala, we have crafted out a very wonderful program on data science and machine learning with iHUB DivyaSampark IIT Roorkee, which is a 4 to 5 month program where we'll be focusing on different applications. So again, we'll be starting that program from scratch, where people who are interested in this particular segment can learn the technique and learn the application of data science and machine learning. This is a course where it is open for all people who have basic knowledge of maths and stats can come in and can do this program. As Sir was explaining, with the skill of Python, etc. So we do have program which we are giving it to learners as a prerequisite Python programming. So people who can register now, the program which we are on data science and machine learning, we are starting the first week of August. So people, and that's where we are finalizing the batch in this current month. People who will complete the enrollment process now will get the access of Python classes, which we are giving it complimentary to each and every individual. They will get that Python lessons. They'll brush up their concepts on Python and will be ready to get into the program once the program will start in first week of August. The program, as I said, the program director of this program is Professor Bala, and there are other professors also who will be helping us learning the concepts coming from IIT Guwahati and IIT Roorkee. So guys, Anita and I have pasted links in the chat box where you can, if you're interested in this program, please fill this application form. Our program counselors or advisors will call you, check your intent of doing this particular program. The program is exclusive. Program has its own selection process where we are checking the intent of each and every learner for the program. They need to submit their statement of purpose also, why they wanted to do this program, where, as I said, the program is just limited to 50 to 60 learner in one batch. We have, so I'll request you, to complete your, fill the admission form. Our counselor will get in touch with you, will talk to you. And then, once that counseling and PI will be done, then the admission form or detailed admission form will be shared with you, where you will be supposed to write a statement of purpose for the program, and then post that you will be once selected, you will get the admission letter and you will be part of the program and you will get the access of Python classes before the program will start. So that's how we have designed the program. Plenty of projects involved. Once the program will start, we'll learn, we'll do, and we'll get this skill in this particular, in this particular course. So guys, please fill the form, which is the link which is shared here in the chat box. And we are really looking forward for further interaction with all of you in the program which we are starting with Professor Bala in IIHUB DivyaSampark IIT Roorkee program with Imarticus, which is on data science and machine learning certification program, professional certification program on data science and machine learning. So once again, guys, thank you so much for joining the webinar, and I'm sure the information and the knowledge which we got it from Professor Bala, I'm sure that has excited you to learn more on data science and machine learning. This is one segment which is expanding in almost all possible industries where industries are dealing it with data points, guys, in optimizing the processes, predicting the results, etc. So thanks again to all the participants who joined this session, and we are looking forward to see you in our programs. Thanks again. I see Bala sir is still here, so thank you so much, Bala sir, for delivering wonderful session. We are great to hear you, sir, and it was. We are looking forward for hearing you again and again in our sessions, in our courses, sir. Thank you so much, sir, and thank you so much, attendees.
Thank you all.
Thank you, sir. Thank you.
Bye-bye.
Thanks. Bye.